Okay, so go ahead. Were you going to say something?
No.
Okay. I'm going to just. I'm having all kinds of tripod issues today. So we have y equals, what was it, x squared plus 2x plus 3?
Yep.
And let's just say it goes up like that, which is maybe not the best sketch in the world. In fact, that's not even an accurate sketch. It goes up like that, so that the tangent line here at least has some slope.
Okay.
And then maybe let's just say here's 6. So we're going to find this area, and we're going to find this tangent line.
All right.
Which one would you like to do first?
Let's do the tangent line first.
Okay. Now we have talked about the area, but we have not ever, as far as I remember, talked about how you might find a tangent line here.
No.
So tangent line to the point 0, 3. So what do you think? What do you think we could do to find what this tangent line is? Or maybe I should even back up further. What do you think the tangent line is?
Well, maybe an approximation. We could say maybe y equals 1/4 x plus 3. We know it has to have a plus 3 in it because the y-intercept is 3.
Oh, okay. Yeah, so it's going to be y equals ax plus 3. That's a very good observation. And then we just have to find what this a is. So what properties do you think the tangent line is going to have?
Well, we know it's only going to hit the parabola at this one point at 0, 3.
Yeah, that's actually almost right. That's true locally. And sorry, I don't mean to make it too pedantic of a point, but if I had a curve that looked like this, and then like here's the tangent line here, maybe it hits the curve somewhere else. But nearby, it certainly only hits the curve at that one point. But the other problem with that definition is, here's our parabola. Maybe that line only hits the curve at that one point.
Oh,
so it's more than just hitting the curve at one point. Something else happens with that tangent line.
Well, it'll have the same slope, I guess, as the parabola will have at that point.
Yeah, in some sense, that line is going to have the same slope as the parabola.
It stays sort of outside the parabola.
Oh yeah, that's a very interesting geometric observation, and also, by the way, a really important point in calculus. That tells us something about the parabola. In this case, the line is staying below the parabola, nearby. Yeah. So we learned something about the parabola from that fact. But, so do you have any thoughts on how we might try to figure out, or even approximate what this line is? Not a lot. Okay, well, how could I find a line, a general line, that touches the parabola at that point, but maybe, or maybe not, maybe isn't, maybe is the tangent line? How could I find another line?
You could just try different slopes for the line, and then they'll all hit the parabola at the same point. Okay, yeah, so any line of this form is going to work. Well, it's a new idea, so I will tell you it, and then in the next video we'll do the calculation. What we're going to do, and we usually call the point h, we're going to look at the point x equals h, and then this is going to be the y point h squared plus 2h plus 3. And then here's the point 0, 3. Yep. And we're going to draw a line that goes through those 2 points on the parabola and has that slope. Oh, I see. And then what are we going to do to find the exact tangent line? We can make h closer and closer to 0 in this case. Yeah, so it's really that straightforward of an idea. We don't know for sure what that exact tangent line is, but we do know how to find a line through 2 points on the parabola. And so we just shrink those 2 points closer and closer together. Alright. Alright, so let's do that calculation in the next video.